Howdy everybody, and welcome to this tutorial on tile-based collisions. As you can see here, I've set up a little base project demonstrating how they'll work once they finally are in the game. We have our little character here trying to get to the flag at the finish. So how do we get this character so that he can move around without falling through the ground? Well, let's figure that out. Let's get cracking. So let's get back into our project here, and I'm going to open up a new character here that I've made that is blank. Well, not completely blank, but it's blank for our purposes. We have eliminated some of the main functions that go into setting up the tile-based collision system so that we can do it here together. We have some simple material in here, such as our frictions and input speed fractions. I'll explain those a little bit too as well in case you need to know about them. And of course our movement, which is what we are going to fill in, and animations. For the most part we don't need to focus on these things. But what we are going to focus on first is our room. So we want to set up a tile-based collision system. To start off, we're going to need some tiles. So we have a layer here called collisions, and I'm using some collision tiles that I created. Just any basic tile set that you create that uses just a couple of sprites. So here I've set it up so that my tile set will have two tiles, well, three tiles if you include the blank space. But our number one tile here is our solid, and our number two here is our platform, which a person can jump up through but not down through. And we have tiled our room with it, and we have our half tiles here and here, which I forgot. And we come back to our blank player object. So we're going to need to set up some things so that the player object can actually detect the ground. So first things first, we need to get a tile set. So come over here into our character and set up our tile map. Tile map underscore is equal to layer underscore tile map underscore get underscore ID. And collisions is the name of our tile layer. I typically always call it collisions for sake of clarity when I'm working on multiple projects. And we also have a second variable that is used very closely with this tile map, which is on ground, because you always need to be able to detect when you are on the ground, right? So we'll add that in as well. First things first, let's get our script set up for moving. So we have the finished version right there, but the one we're going to start with is move underscore with underscore tile underscore collisions underscore blank. Now I've set up this script so that you can give it a couple of variables, and it will take those arguments and use them. This would be the tile map, the X speed, and the Y speed. So let's come back over to you and feed those variables in. Tile map underscore, X underscore speed underscore, and Y underscore speed underscore. And I built it this way in hopes that the script will actually be able to work with multiple objects. So if you have multiple things that you want to have moving around. And again, even if you do that, you might want to end up having a move underscore with underscore tile under collisions underscore player version where you have special characters, special cases for the character, and so on and so forth. But yeah, the main reason why I'm doing this is because back when I did my tutorial for Legacy of the Wizard, I think one of my biggest disappointments was that I kind of flaked on describing how tile collisions worked. That was mainly because I had done well, it was just fine in there, but the way I set it all up was so terrible, it was hard to actually describe to people what the tile script, what the collision script was actually doing. So I decided to rebuild it from first principles and make it much nicer and easier to work with so that it would be easy to understand. So first things first, we are going to start working on our horizontal collisions. Pound region, horizontal collisions, pound region, pound end region. And we're going to want to set up some variables to get us started. So we want var underscore bbox underscore check underscore p1 underscore p2 underscore current underscore cell underscore target underscore cell underscore target underscore x underscore target underscore y and underscore cells. And we are going to want to detect which direction we are moving in, because that will determine what side we are going to check for a collision. So if underscore x underscore speed is greater than or equal to 0, then underscore b box underscore check is equal to b box underscore right. And else underscore b box underscore check is equal to b box underscore left. And you might be wondering why these aren't yellow yet, and that's probably because GameMaker is being slow on the uptake that I declared some new variables. They'll work later on once I actually start using them. So we want to be able to detect what square our character is in. So if we come here and we come back to our collisions, our character here is this guy, and his bounding box is a little something like this. And first things first, we're going to do is, if we're going right, we get the bounding box right. So that would be where the player character's right side is. And we want to check what cell that is in, because all of these cells, all these tiles on the collision layer are called cells, and they are numbered on the X values from 0, 1, 2, 3, 4, etc. And of course 0, 1, 2, 3, 4 on the Y's on the way back down. So we determine which cell we are in. Underscore current underscore cell is equal to underscore b box underscore check div tile underscore width. So that will let us know what X cell we are in. Tile underscore width is a macro that I set up here over in the player character. You can set these up wherever. That describes how wide the collision tiles are. So in this case, 70 pixels. And the height is also 70 pixels. And theoretically, though I haven't actually tested it, you can have any width and any height, and it should work with this script just fine. So that will give us div. So let's say we're at 32 and we wanted to check with a tile width of 4. That would tell us that our right bounding box is in cell 8. So then we go underscore target underscore cell is equal to underscore b box underscore check plus underscore x underscore speed div tile underscore width. So this is the cell that we actually want to move into. So again, if the tile width is 4 and our x speed is 5, then we take our 32 plus 5 gives us a value of 37, which divided by our tile width again here would give us, so 32 divided by 4 would give us 9. Yeah, 9. So we're trying to move into cell 9. So we want to check cell 9 to make sure that there are no collision tiles inside of cell 9. Underscore cells is equal to AVS underscore target underscore cell minus underscore current underscore cell. So this is how many cells that we are going to check. So how many cells over we're going to check. So target cell 9 minus 8 gives us 1. We want to check one cell to the right. And we'll be using that for checking each cell between our player position and the position that we're trying to move to make sure that there are no collision cells in between those two positions. So if underscore target underscore cell is equal to underscore current underscore cell, x plus equal underscore x underscore speed. If the target cell is the current cell, well, we are already in that cell, and theoretically there's actually no collision inside of that cell. So x plus equal x speed. There's no need to check for a collision because theoretically we've already checked for a collision in this location. And the consequences of which is that if for some reason you did manage to clip into a wall, you'd be able to move perfectly normally as if there were no collisions at all inside of that wall. And that's actually how collisions work in Super Mario in the NES game. So, in fact, this entire setup is pretty similar to how it actually worked in the NES Super Mario game. So, but if our target cell is not our current cell, we are going to want to do some collision checking. So we are going to want to start looping for var I equal 1, while I is less than or equal to underscore cells I plus plus. And this will loop us through each one of those cells that we detected between us and the target cell. Like I said, for checking to make sure that there are no X collisions between us and our target. So if I come back here, we go underscore target underscore X, because we need to return our cell back into an X value so that we know where we're trying to actually move to. Underscore current underscore cell plus I times sine of underscore x underscore speed times tile underscore width. So our target x is our current cell plus I times sine of x speed. So if we have, this will make it so that the for loop is independent of whether we are going left or right. So if we are going right, then it will make our target x be in a more positive value. So if we are trying to move one cell, so we would then have our current cell plus 1 because you had sine times x speed, which would be a positive value for moving right. And that would give us a positive value. And if we're moving left, this would become a negative value, and it would subtract for our current x value. And then we need to check for a collision at that location. Get at pixel underscore tile map underscore target underscore x and b box underscore top. And why are we checking at the top? So is our tile collisions, we are checking at the top of the player character's collision box for a collision. So we'd be checking right there to see if there's a collision. And we're also going to add a second collision check, which would be right there at the bottom for a collision check. Now, typically this would not be an issue as long as our character is the same size as our room. Is the same size or less than our collision tiles, or as far as it goes, the collision tiles' largest gathering. So in this case, the character here is in fact slightly bigger than the collisions right there. So he is his collision box is slightly taller than the then 2 tiles right there, so you can actually clip through. But you can't clip through if the collision happens at the top or at the bottom. So in this case, since the character is a bit taller than both of these, I would actually put a 3rd collision check right there at the center, and that would prevent him from being able to clip into this wall as well. But I'm not going to go into doing that right now. I'm just going to do the top and bottom for the right now. So we're also going to have P2. Go timeout underscore get at the bottom. So we know where we want to check, and we know where we want to check at. So we want to check at cell 9, and we want to check at the top of our collision box and at the bottom of our collision box to see if they are hitting something in cell 9. So what are we going to do if they do? So if underscore P1 is equal to 1, in this case our solid block, or underscore P2 is equal to 1, or underscore P1, actually we don't need another or at this time, I believe. That's a check in my other script that I'm using. So we are checking for the P1 and the P2, and if underscore x underscore speed is greater than 0, then x is equal to underscore target underscore x plus x minus b box underscore check minus 1. So if we're going right, let's see, we said we were at 32 and we wanted to move 5 pixels over, so that would get us back over into 30 at x equals 37. But in this case, we're going to say there is a collision tile in cell 9, so therefore we should be colliding with that. So with this setup, we have set our target X as being in cell 9, and our P1 at the top should be detecting that target X at the B box top has detected, or B box bottom, either one, has detected a collision. So underscore P1 is equal to 1 and underscore P2 is equal to 1, and we set our X equal to the values such that it is our target X. So our target X is 36 plus X minus B box checks minus 1, which would be the distance from our X position to our right bounding box. So our X position in this case is right here. Our right bounding box is over here. And minus 1. And that's our offset, so that we appear exactly on the right edge of the tile. So let's come back over here and let's come back to our main player object here. I'm going to make the bounding box visible on him so that you can see what's happening. And do a run so you can see his bounding box. We walk over there. Setting that position makes it so that his bounding box snugs right up with the X position of that tiles, of those collision tiles right there. And also back over here, you can get rid of the window sizing so that it stays in a window rather than a full screen. And we also need to check on our left, else x is equal to underscore target underscore x plus tile underscore width plus x minus b box underscore check. There we go. So again, if we were going left, so if we were at 32, which is tile 8, and we wanted to go left by one tile into tile from tile 8 into tile 7. Our target X would be 28. So we add the tile width. So that would be 28 plus, in this case, would be 4. So that would give us a value of 32. And then we also add in the offset from the X position of our characters minus the bounding box, so that we can get the distance from that we should offset them from our left side as well, so that the character appears to collide directly with the left edge. So again, our character goes right over there and collides directly with that left edge perfectly. However, we need to do one more thing. We also need to remember underscore x underscore speed is equal to 0. Because if we don't reset our speed back to 0, then well, our character will move regardless. And well, they wouldn't move per se, but they would retain speed, which we don't want them to retain. So I mean, if we slide them up against the side of a wall, and we don't want them to be animating while they're trying to walk into the wall, so we just set our X speed equal to 0, so they remember not, so that if you have your animations set up to not animate, if you have an X speed of 0, then you won't animate. And we're actually going to return this value at the end of the script, so return and underscore x underscore speed and underscore y underscore speed as well. Return those as an array so that we can then come back into our character and reset our x speed equal to y underscore speed underscore is equal to underscore speed 1. There we go. That way we can get our new speed values out of the script. So that's pretty good so far. And we also need to remember that if no collision was detected when we were moving, we need to also add our underscore x underscore speed. And that's everything for our horizontal collisions. As far as it goes, the horizontal collisions are generally the easiest ones. I mean, as far as in my experience so far, horizontal has always been the easiest, that need the least code. Because then you get into verticals where you need to be able to jump, and then you have platforms that you want to be able to walk through, and so on and so forth. And then you start having trouble at that point because you have to start adding all sorts of special cases for the verticals. So let's get started on that as well. Let's add a region. Why aren't you going? Why aren't you auto changing? Oh well. Pound region vertical collisions. Pound end region. And the regioning is just for my own benefit. You don't have to do it if you don't want to, but it makes things easier to organize. So let's go if underscore y underscore speed is greater than or equal to 0. Then underscore b box underscore check is equal to b box underscore bottom. Else underscore b box underscore check is equal to b box underscore top. So we're going to be checking on our tops and bottoms here. Let's get a little space there. So if our y underscore speed is greater than or equal to 0, that means we are falling, so check our bottom. Otherwise, check our top. And again, we're going to use a lot of these. We're going to use all these same variables that we set up earlier. So underscore current underscore cell is equal to underscore bbox underscore check div tile underscore height in this case underscore current underscore underscore target underscore cell is equal to underscore bbox underscore check plus underscore y underscore speed div tile underscore height and underscore cell is equal to abs underscore target underscore cell minus underscore current underscore cell. All right, so next up, again, if underscore target underscore cell is equal to underscore current underscore cell, we don't need to check for a collision, so y plus equal underscore y underscore speed. But if a collision is being tested for, then for var I equal 1, while I is less than or equal to underscore cells I plus plus. And underscore target underscore y is equal to underscore current underscore cell plus I times sine of underscore y underscore speed times tile underscore height. You can see a lot of this code is pretty much exactly the same, except we're just kind of slightly varying it so that it'll work more properly with the y rather than x. So target is exactly the same, plus I times sine speed times height. And again, we are going to be checking for some tile map collisions, except we want to swap these around so that we are checking bbox underscore right underscore target underscore y and bbox underscore left underscore target underscore y. Because when we are checking for verticals, again, we are checking on the left and the right of the top, the left and the right of the bottom. If underscore p1 is equal to 1 or underscore p2 is equal to 1, again, checking for solids. Then if underscore y underscore speed is greater than 0, going down, y is equal to underscore target underscore y minus 1 minus underscore bbox underscore check minus y. So again, y is equal to our target's y position minus 1 minus the, well, I think I probably could put this into here as well, the same as the with this one right here. So we're checking out, doing our bbox check minus our y position. So that'll give us a value, an offset value for from our origin to our sprite bounding box, and subtract 1 and give us our target y position. And that should put us directly underneath where we want to be. Else, y is equal to underscore target underscore y plus tile underscore height plus y minus bbox underscore bbox underscore check. Yeah, so I mean it's almost exactly identical, except just change the tile height for y for the tile width for height. And last but not least, underscore y underscore speed is equal to 0. So this will check for our solids and make sure that everything's going well, that we have hit a solid and let us collide properly. Before we get too much further at this point, I'm going to go back to our player character because there's that other variable I set up earlier, on ground. We are going to need to be checking for our ground position. So let's go back to you to make sure that we're actually touching the ground. That way our character will know to whether or not he's on the ground and whether or not he should be falling through it or not, or whether or not he can actually, jump or not, and we need to be able to jump. So we're going to come back over here to you, and I'll just copy and paste this code out of here. And come back here, put it in between the friction and the input. And we have 4 vars, so underscore P1, P2, P3, P4, because we are going to do 4-point checks. For the moment, actually, we can ignore P2 and P4 as far as it goes. Not P2 and P4, P1 and P3 we can kind of ignore at the moment. What we're doing here is we're getting at our current position on the left and the bottom, so +1. So the pixel directly underneath our character on the left and the pixel directly beneath our character on the right. And we are going to check to make sure that they are a tile that is greater than 1, or else, and that is also that it is equal to 0. So if there's a blank space on our left, I guess I'll add all these things in here. So we are checking the tile directly where our character is and the tile directly underneath our character. We want to make sure that the tile that our character is in is an empty tile, and that the tile directly underneath our character is a solid tile of some kind. And again, on our right side, so we have underscore P1 is equal to 0 and this. So both of these options have to be true in this case. So this would be the left side, and this would be the right side of our character. If either one of these are true, and our y underscore speed is equal to 0, then we are on the ground. And the reason why we're checking inside of our character's position as well as the tile directly underneath our character is because if we were to say be passing through a platform tile right here, and we were just checking the tile that is directly underneath our character, and we reached a y speed equal to 0 at this point, then our character would think it's on the ground and would no longer be adding would no longer be adding gravity to it itself, so it would stop moving at that point. That's just the way I've set things up. So I mean, it kind of really depends on how you set things up. So you might not need to do it depending on how you set things up. But we need to be able to check if we're on the ground so that our character can actually move around without having trouble. So let's actually come over here and add our new character to the room. And hopefully there won't be any errors. Yeah, see, there he is. And he's not able to check that he's jumping, apparently. If up and on ground, why are you not being able to jump? Because on ground is equal to false, and that's because you are not at a y speed equal to 0. That would be because I put you in front of the frictions. I guess probably need to be right here, maybe. There we go. Yep, there he is. As you can see, he has some trouble still. go back to this guy here. And yeah, well, the friction and gravity. I actually put this in between both of those. Anyway, so you can see he's hidden his head on there and he's just fine. He can walk over to the wall and he's just fine. Walk over to that wall and he's just fine. I'll figure out why he's having trouble with that later on. But let's see. There's some other things that we need to do to make this collision script the most powerful it can possibly be. So, like I said earlier, there can be some special cases like working with the platforms. So, how are we going to handle those? Well, let's come on over here to the main script here, and I'll describe what I've done to handle those. Let's make sure I actually added some stuff here. So, or underscore p1 is equal to 3. I have no idea why I put that in there. Probably because I was copying it from my other project. So I can ignore that for the time being. Let's see. So in this case, P1 is equal to 1, P1 is equal to 3. But if we were to be hidden a platform, /2 is equal to platform, then we are going to want to apply some special checks. So if y underscore speed is greater than 0, if we are going down and our current cell does not equal our target cell. So this is important here because if you don't have that, then you can get stuck inside of a platform tile because you would stop thinking that you're well, you can move up through a tile, so then your collision position would then be 8 and 8 at the same time. Your current cell would be 8, your target cell would be 8, but the target cell is also a collision cell, so you would be you would be detected as being on the ground, so you wouldn't have gravity. And in this case, having the underscore target cell allows you to move through the platform properly. So we set our Y speed going down, but we don't check for going up because we don't want to take collisions when we're going up with this when we are doing a platform. So then we say again, just the Y equals this. We don't do anything special there. Enclose this or you bonk your heads on platforms because yeah, this has to be inside of the check, because if it's otherwise you would hit your head when you're going past it. So yeah, I think that's about everything for this as far as it goes. But as you can see, so this works just fine with regular full collision tiles. It also works fine with platforms. And I think, in fact, if you really wanted to, you could probably switch this script up just a little bit, and you could actually make it work with tiles that you set up with. If you do a tile map that is a 1x1, you could actually set it up so that your player can walk up slopes. If you set a middle X bottom collision, that would be your collision detection right there in the middle of your character, so he looks like he's walking up a slope as well. So anyways, this is the tile collision system that I've come up with, and it seems to work so well so far. But if you have any trouble with it, let me know. I'm hoping that everything works just fine for everybody. Oh yeah, we also had the speed fractions back here, so I think this tile collision system will work just well without it. But if you wanted to, you could actually get rid of so if your character had like a 8.5 movement speed, so you're moving 0.5 pixels, you would store the 0.5 pixels into a fraction, which you would then bring back into play next next frame, or once you've stored up enough fraction to equal a whole number. So if you had a y fraction, in this case I've set it so that when you're on the ground your y fraction is deleted, and in this case the y fraction would also be deleted, but we take our x speed. So if you're 8.5, then you add in your x fraction, let's just say it's 0 for the moment, and our x underscore fraction is equal to x speed, so 8.5 minus the floor, the absolute value of x speed, so 8.5 floored, so that would be 8 times the sine of the x speed. So in this case, let's say we're going right, so it would be just 1. So x speed would be 8.5 minus 8, so that would give us a value of 0.5 would be the x fraction that we would store. Then we take our x speed and subtract from it the x fraction, so that it will now be that in this frame we go 8 pixels. But if we were to come back the next frame, then our x fraction would be 0.5 and our x speed would again be 8.5, and we add in that x fraction, so now our x speed is equal to 9, and it would detect 0 at that point, and you would then move 9 pixels the next frame. So you'd move 8 pixels, then 9 pixels, 8 pixels, 9 pixels, so on and so forth. And the exact same thing for the y speed as well. It's just the exact same code, just change it with y underscore speed. And it just has some animations and stuff. Yeah, I think that's pretty much everything as far as the code for this movement when that goes. So thank you everybody for following along, and I hope this helps if you are making yourself a platformer or an RPG or any game really, because this collision system should work just fine in any game type. And like I said, it is able to detect your movements. So if you wanted to move your character at 500 pixels per frame, it would detect any collision between you and those 500 pixels that you're trying to move. So your character speed shouldn't matter in the slightest for this this collision system. Plus, it's using cell positions, so it should be about as fast as you can possibly get it as a tile system goes. And I can't really, and like I said, just if you tinker with it, you can probably even get it to work with slopes. So if you really wanted to do just like a 1x1 tile collision system, you could do 1x1 to be able to move up slopes properly. At least the math worked out in my head when I was thinking about it last night. So I haven't done it myself yet. Maybe I'll do another video in the future where I actually do it. Anyways, I'm very bad at ending things. So thank you everybody for watching, and good luck with your programming.